Hi everyone and welcome back to PrepFusion. So today we will start with the assignment solutions of whatever I gave you as homework in the previous lecture. So this was the first question basically. So we have a load and mostly these questions are from the Sadico book. So we have a load of VRMS and IRMS, okay, whose voltage is this and current is this, RMS, these are all RMS values, okay. So we have to determine the complex and the apparent power. So first let's discuss about the complex power. Complex power is simply S equals to V into I conjugate. Okay, apparent power is basically the magnitude of the apparent power. That's it. Apparent power is the magnitude of the apparent power is the magnitude of the complex power. Okay, so this is the complex power, and apparent power is the magnitude of the complex power basically. So this is my apparent power. Okay, so now let's first do one by one. Let's first solve over the complex power. So complex power will be what? This is VI conjugate. So V is 110 angle 85. What is I conjugate? I will be 3. Magnitude will not change, but angle will become negative basically. 3 angle minus 15. So this will be 330 angle 60 degrees. Okay, this is my complex power basically. This is my complex power, volt ampere. Okay, so sorry, not 60 actually. This will be 70. This will be 70 degrees, right? Yeah, this will be the apparent power. Now no, this will be the complex power. What about the apparent power? Apparent power is the magnitude. So apparent power is simply magnitude of S or magnitude of V into magnitude of I, which is simply magnitude of S, which is 330 volt ampere. This is the apparent power. Okay, what about the next? What they have asked, this is the part A. In the part B, they have asked for the real and the reactive powers. So real power is what basically? So real power, right? If I break this down into the rectangular format, so if I break this down into the rectangular format, this will be 330 cos 70 degree plus j sine 70 degrees. Okay, so what is cos 70? Cos 70 is 0.34. Cos 70 is 0.34 and sine 70 is 0.94. So from here, right, you can break down basically into real and imaginary part. So into 330, this will be 3j 312 plus, if I do 330 into what is cos 70.34, so it will be 112. Okay, this is my apparent power. This is the real part of the power. This is the reactive part. Okay, this is Q and this is the real part basically. So from here I think you can bifurcate. Your active power will be 112.2 watts and your reactive power will be basically 312 volt ampere reactive. Okay, so it is positive. We are getting positive because hence it is a lagging reactive power. You can see from here as well. If you see, your current is lagging the voltage, right? Your current is lagging the voltage, so it is making sense. So that's why we took it as a reference. That's why we took it as a reference that my theta v is greater than theta I, and that's why we took Q to be positive if theta v was greater than theta I. That is the reasoning. Okay, now in the previous lecture I told you, right, you can ignore the fact, but like bit of reference we have taken. What kind of reference? We have assumed that lagging means theta, like current lags voltage, that means it is lagging. And if current leads the voltage, it is leading. So that is our reference, right? So according to that reference, if Q is positive, that means it is a lagging reactive power. That means it is a lagging load. So that can be verified from here as well. And if Q is positive, that can be verified from here as well, that it will be a lagging load. Okay, in the previous lecture I did not mention this very well, so I think now it is more clearer. Next part is they are asking the power factor. So as everything is defined in phasor only, so assumption is they are in the same frequency and it is a single frequency component. So power factor is the angle between the voltage and current. Okay, so power factor PF is equals to cos of theta v minus theta I. Okay, so cos of theta v is 85 and theta I is 15. Okay, cos of theta v minus theta I. Okay, so yeah, that is the case over here basically. So now what is this? This is cos of 70. Cos of 70. Cos of 70 is what? Cos of 70 if I do is 0.3 to 4 3 point 0.340 basically. Cos of 70 is 0.342. Okay, lagging. This you should always specify. This you should always specify. Now the important fact is basically that what you have to remember is that I can write the same expression with the actual definition of power factor, that is P by magnitude of this S. This will always be valid. This will always be valid. So what is the power? Active power. Active power is written over here, right? 112.2 watts. It is 112.2 watts divided by the apparent power. Apparent power is basically 330, right? That is the magnitude. Apparent power is 330. So this will be 330. Okay, so 112.2 divided by 330. So this will be 0.34. Again, it is lagging because we know it is a lagging, like the current is lagging the voltage, that's why. Okay, so from this will always be valid. So both ways you can find out the power factor, but this is a better way. The second method is a better way. The second, like the third part, this is the okay, this is the B part, right? This was the B part, I believe, correct? And the third part they are asking the power. Okay, power factor is the third part, and also the impedance, load impedance. So what is load impedance basically? So if I have this complex network, right? What is it? Yeah, if I have this complex network and I know the voltage and current, so let me, if I have this complex network, and I know the voltage and current. What is the voltage? Voltage, right? I'm sorry for the background noise. I'm really extremely sorry. I hope they will stop this noise. Some construction work is going on. So voltage is basically this, right? Voltage is 110 angle 85. Voltage is 110 angle 85. 110 angle 85. Okay. What about the current? Current is 3 angle 15. Current is 3 angle 15. Current is 3 angle 15. Now of course I can find out the impedance. What is impedance? Impedance will be simply V upon I, right? So it is 110 angle 85 divided by 3 angle 15. So from here as well you can find out the impedance angle, which will be same as the power factor angle. So again, impedance angle is positive, that means it will be lagging. That is the convention. So V RMS by IRMS, so it is 110 divided by 3 basically. So it is 36.67 angle of 70 degrees. Okay, so this is my impedance. Okay, and from here, like, you can write this in your rectangular as well, into whatever you can break it down, right? Your impedance will come out to be positive. If I just want to write the phasor. So this is the real component of the phasor, and this will be my JXL, okay, JXL, and overall impedance will be here, Z equals to R plus JXL. Assumption is I am assuming it to be a basically series circuit, right? It can be anything. Assumption is equivalent. Equivalently, I am assuming it to be a series circuit. Of course, you can break this down, right? You can break it down into different components. That is cos of 70. What is cos of 70? It is 12.54 plus 70 sine into 36.67 J .458. Okay, so this is the ohm basically. This is the ohm. Okay, so yeah, I hope you have understood this basic thing. This was the impedance. So the XL is this one, XL is this one 34, and this is the R. Okay, so this was the very basic first question. Now there is one very common query and doubt in the mind of the students, that if a network is given and this phasor format is given, should I choose RMS or peak? What should I choose? Should I assume this value to be peak or RMS? So many teachers will tell you many things. First point one is gate examination. Normally they will tell you, normally information somehow you will be able to see from the question that normally information will be given that whether this is RMS or peak. Okay, normally it will be given. It is standard. They will be given. Either they will say it is peak or they will say it is RMS. You will be able to understand from the question. But in case, sir, what if they don't tell you? There is no way to find out, right? Then what you will understand, whether this 5 is the peak value of the sinusoid or is this the RMS value of the sinusoid. So by default, like let's say, because what will be the problem if you go ahead with the peak value, right? If you assume this to be peak, these to be peak, so basically then you write that my Vm is 5 volts, my Im is 1 amperes. Peak values, what is my power? Peak power, so not peak power, sorry, the average power, it is Vm Im by 2 cos phi. Okay, Vm by 2 cos phi. So angle is okay, angle is fine, like there is no peak or RMS for angle, so it is simply cos 60, correct? Vm by 2 cos 60, so it is 5 into 1 divided by 2 into cos 60. Cos 60 is 1 by 2, so it is 1.25 volts. Now let's say if like this was student 1, okay, and there is some student 2 in the same examination, he assumed it to be RMS. If he assumed it to be RMS, then what will be the difference? If he assumed it to be the RMS, then what will be the difference? So then the difference will be he will assume it to be RMS, right? So my VRMS is 5, my IRMS is 1 ampere, and my cos phi is, that is 60 only, right? So here the what formula I will use? Same formula only, like just bit interchange. It is VRMS into IRMS into cos phi. So it is VRMS into IRMS into cos phi. Okay, so it is basically equals to VRMS is 5, IRMS is 1, cos phi is cos 60. Cos 60 is 1 by 2, correct? So it will be 2.5. So of course both are getting different answers. So which one shall I choose and which one will be correct? So although this should not happen, actually this will never, most probably this will not happen, but just in case, you will always go with the RMS. By default you will go with the RMS. Nothing is mentioned, by default you will go with the RMS, you will not go with the peak. If nothing is mentioned about these phasors, whether this is peak or RMS, you will choose this to be the RMS only. You will not assume these to be the peak values. You will not assume these to be the peak values of my sinusoid. You will assume these to be the RMS values. Why? Because RMS is a very standard thing. Okay, RMS is defined with power and all those things. That's why. Now there is no particular explanation, but in most cases we choose this to be RMS only. Okay, but again I'm reiterating that again in the examination hall they will tell you, whether this is peak or RMS. Now don't go blindly and just assume this will always be the RMS. No, this will not always be RMS. In the question they will mention if this is the peak value, 5 is the peak value or the RMS. But just in case if it is not mentioned somehow, then by default you will choose RMS. If it is mentioned, then you will not choose it as RMS. Whatever the question examiner has told you to choose, that you will choose. Got it? Great. If got it, then comment down below that I have got, whether I have to choose RMS or peak. Write down in the comments below. So that was the small confusion I have seen many students have. So we have cleared the confusion. Now this is the next question. We have the voltage across the circuit in the figure and the current through it is also given. Okay, and it has DC component and AC component as well. Omega is 100 pi. If the average power delivered to the circuit is 0, average power is 0. How can it be possible? Average power 0 means DC component is sending some power, that is fine because both are positive, both are of same sign. So DC will send some power, but in this AC part, right, some component is overall there is negative power. Basically the load is supplying. So overall the power is 0 somehow, average power. So we have to find out the value of x if the average power is 0. If the average power is 0, we have to find out the value of x. So my V of t is this, x of t is this. So power, right, what is average power? Fundamental formula for average power was what? P average is 1 by t integration of 0 to t the instantaneous power. Okay, or I can write V of t into I of t d omega t. Why omega t? Because here I am representing my sign in terms of omega t. That is the only reason. And this also will be in radians only. Okay, and they have mentioned this to be equal to 0. So I will put the values here. I will simply put the values. What is the time period? Time period, what is the time period? So the time period of this waveform, right, will be 2 pi only. The time period of this waveform will be 2 pi. Let me check this. Yes, the time period of this waveform will be 2 pi. Because like for this you have to study a bit of signals, but just little small idea I will give. So if you multiply these components, right, if I multiply these two components, what will I get? What will be my instantaneous power P of t? This will be 25 plus 5x cos of omega t minus 50 cos of omega t (60), then minus 10 cos omega t plus 60 degrees. Okay, so like okay 10x is there and cos omega t is getting multiplied, right? Cos omega t is getting multiplied. Okay, so what is the frequency of this term? This is DC, right? This is simply DC, so it does not have frequency. So this is constant always. 25 will always be there, no matter what 25 will always be there. What about this term? Its frequency is 2 pi. Sorry, its time period is 2 pi. What about this one? Its time period is also 2 pi. What about this one? Cos A cos B. So cos A cos B I can break down. Cos A cos B I can actually break down. So if I break down cos A cos B, again I will forget the formula. What is the formula for cos A cos B? So cos A cos B. What I remember, if I remember it correctly, it is cos A plus B. Hold on a second. Cos A plus B. I think it is plus cos A minus B. Okay, I will just quickly confirm this. I will quickly confirm this. If it is cos A plus B minus cos A minus, I am really bad in trigonometry. Okay, like I forgot the formulas. So let me just quickly confirm to cos A cos B. Okay, cos A cos B formula. So yes, it is correct one. Yeah, it is correct. So it is cos A plus B plus cos A minus B. So you can break it down basically. This will, right, this ultimately this will become A plus B is omega t, 2 omega t plus 60, 2 omega t plus 60, then it is 60 degrees only. Okay. So yeah, now this, right, this is constant term, this will, the other one will be basically constant independent of time, this one will be 2 omega t which is dependent of time, okay, which is dependent of time. Now I know this whole waveform, right, will be periodic about 2 pi, this whole waveform will be always periodic about 2 pi, and anyways the average value of any cos, right, cos term will be simply 0, so this one will anyways go away. What do I mean? What do I mean by this? What do I mean by it? I have four signals, right? This will be, let's assume this to be x1, these to be x2, these to be x3, this to be combination of two signals x4 plus x5, correct? One of them has a function of 2 omega t, other one is constant like 60 degrees, like cos A cos B. Okay. Now if I want to calculate the overall average power, so obviously this one is constant, the average of 25 is 25 only, a constant number, average of that constant number will be 25 only, so this will be 25 only. Okay. What about the other terms? So what is the average of this cos omega t? What is the average of a cosine or sinusoid? 0. The average of a cosine or sinusoid is simply 0, so it goes away, 0. What is the average again of a cosinusoid or sinusoid? 0, right? Average area of a sinusoid is 0 only, right? Over a period area is 0, so it is 0. Then I have a negative sign here, and of course I have to multiply and divide by 2 because I need the 2ab formula. So if I multiply and divide by 2, this will be 10 by 2 basically, and inside I will have a term with cos 2 omega t plus 60. So that term, right, again that is a cos term. If that is a cos term, again the average of that term will be again 0 because it is simply a cosinusoid, and average of any cosinusoid or sinusoid is 0. Okay. What about the other one? This was what? Cos into a minus b, so this is cos 60. This one will not be 0, right? This one will not be 0, cos 60 will stay because it is a constant. Cos 60 is a constant number, half. Cos 60 is a constant number, half, and of course don't forget there is a x outside as well, so there is a x here. Okay. So this value will come out to be 25 minus 5x into 1 by 2 is there, right? So this will be 5x by 4. Now in the question, what have they told us? In the question they have told me that this average power, right, is actually equals to 0. So this will be equals to 0. Now I hope you are understanding why is it equal to 0, due to this component, because it is negative, because this is negative, due to due to this component I am getting it 0. Okay. So this will be equals to x equals to 20. So your answer will come out to be is it 25? Yeah, it will be am I doing some mistake, because actually the answer is not 20. What kind of mistake am I doing? Okay, 10 10. Okay, 25 is here. This integration is simply 0, this is 0. Okay, 10x by 2, that is 5. Okay. This is 5 in 5 by 2. Sorry. This is 5 by 2, right? Sorry, this is 5 by 2. So this 5, because I know the answer, right? So answer should be 10. So that is what I was making mistake. X is 10. Okay, 10 what? What is the unit of x? Can you tell me what is the unit of x? It is amperes. In the first lecture of phasor, we have discussed what should be the unit of the amplitude. So it is 10 amperes, and this is the answer basically. Okay, so this was the first method, which was obviously the basics. Okay, we cleared it with simply the basics, right? Now what about any other method? Is there any other method with which we can solve basically? Is there any other method with which we can solve? Okay, so method 2 is one thing, you know, the power, right? Power will be either due to the matching frequency components. So why? The reason being all other signals are orthogonal. So this 5 into cos omega t, right? This 5 has a frequency of 0, and this cos omega t has a frequency of omega. So whenever I have different frequency components, right, they are orthogonal to each other, and if I just integrate the product of these two functions, it will be 0. Why it will be 0? Because these two signals are orthogonal to each other. I've already explained this, that if I have two signals of different frequencies, right, and if I multiply, like I'm talking specifically for sine, okay, sine and a constant signal, basically if I multiply those two signals are orthogonal to each other. Orthogonal to each other meaning, if I multiply those two signals, then I integrate over its time period, it will come out to be 0. That is the definition. So these two signals, 0 and like this multiplication and this multiplication, these two signals are orthogonal to each other. As these are orthogonal, of course they will not consume any power. So method 2 is using the orthogonality property. Using the method 2, using orthogonality property. Okay, so basically what is orthogonality property? Thus this phi and cos omega t are two orthogonal signals, so their product and their integration will be 0 simply over a period. Over a period, their product, the integration of their product will be 0. So ultimately this factor comes out to be 0. Another DC signal I have, this is the other DC signal, basically this one, right, 10 and 5, right. So this minus 10 cos omega t plus 60 and 5, again the product of these two signals, orthogonality will be 0, like basically they are orthogonal, so power will be 0. Okay, so basically just hold on, yeah, so basically like same thing we have did, right. I have derived here why they are 0, and here I have just used the property. The same thing I have did here, right. I told you that this integration will be 0, this integration will be 0, I have written it, right. This is 0, this is 0. I am just using the property. Got it? Power will be only due to the purely DC sources like 5 into 5 and the purely AC components which has same frequency. Let's say I had another signal here cos 2 omega t plus some value 90 or some 45 degrees. So basically the power due to this 2 omega frequency, right, power due to this 2 omega frequency will be simply 0. Why? Because I don't have any matching frequency here. I should have in the current another frequency term, that is 2 omega. Okay, let's say y cos 2 omega t plus some random angle. Okay, so if this frequency term is present, then the power due to this 2 omega t will be there in this component, right. But due to all of these component, the product will be simply, the integration of the product will be 0. Only for these two product the integration will not be 0. Because why? Because I will get a constant term due to the formula. I will get a constant term here. So basically that is the main thing. So what is the constant term here? Power will be due to this, power will be due to 5 into 5. Okay, that is the DC power, that is V into I, that is 25. And what is the other power? Other power is due to this component 10, not this one, I think this this, yeah, minus 10 cos omega t plus 60 and x cos omega t. So this is minus 10 cos omega t plus 60 and x cos omega t. Okay, so if I take the product of these two things, again you will get a, what will you get? Simply what you can directly say is you will get a term of cos a cos b, and ultimately it will be 10x by 2 into cos a minus b, because cos a plus b, the term will be 0. Or directly what you can say, this is the voltage, let's say this is the voltage and this is the current, right. Because DC part has been taken care of, this 5 into 5 DC part has been already taken care of. We have already calculated the power due to the DC source. Okay, I can divide this into a DC source and a AC source. So in the DC source the power has been already taken care of. For the AC source, the voltage signal is this minus 10 cos omega t plus 60. Here is the voltage signal, minus 10 cos omega t plus 60, and the current signal is x cos omega t. So if the voltage signal is minus 10 cos omega t plus 60 and the current signal is x cos omega t, what can you say? You can directly write the formula of power. Power is what? Vm Im cos omega t. So this is the only due to the AC source, and this I am discussing only due to the DC source. Okay, it is Vm Im by 2 cos omega t, cos theta, cos phi. So it is x into 10. I don't care about the sign because in power, right, ultimately we will get some positive number only. Oh no, we do care about the sign. Sorry, we do care about the sign because it will deliver the power, right? Sorry, it will deliver the power. That's why I have to write the negative sign. I have to write with the negative sign. So this will be minus by 2 into the angle difference between these two, the angle difference. So of course, if I observe that this time, right, the voltage is leading the current because it is, they have same reference as cos omega t. If I assume cos omega t to be the reference, the voltage leads the current. Okay, so this will be cos of phi. If there is any doubt in this method, right, please don't use this. I have already mathematically proven it to you how we are getting to the result. Okay, this is for only those students. This is for only those students who are like, who want to solve in a quicker manner. So I will like take another like term as well. There we will understand this better. So AC will be 10 into minus x divided by 2. This will be equals to minus 5 divided by 2 into x. So ultimately the overall power is PDC plus PAC. So P is equals to 0 is equals to PDC plus PAC. It is minus plus minus 5 divided by 2x. Okay, this is equals to 0. So my x is equals to 10. From here also you get the x 10. Now let's check another example. Let me take another example. So the same example only. Let's say these three were my signals. Now from here you can, like, if you use a shortcut, okay, although this is not a shortcut, basically we are deriving the result only. But if you want to use a shortcut, what you will do is you will write the DC power. DC power is 25 only, 5 into 5. Okay, what is the AC power? Now as these are different frequency components, so the power due to this and power due to this I can simply add, because these are different frequency components. Otherwise I would not be able to do it. So that's why you are using shortcut, but try to understand when you can use a shortcut. So PAC I can directly write here. PAC will be the power due to the frequency component of omega and plus power due to the frequency component of 2 omega. For all other product, right, for all other multiplication, power will be 0 because those signals are orthogonal to each other. Got it? So power due to omega we have just calculated. It is Vi cos phi, right? Vm Im by 2 into cos of phi. So Vm is 10 divided by 10 into x divided by 2 Vm Im cos phi, and of course minus sign is there. Cos phi is 60. Okay, plus what? Plus the power due to the 2 omega component. Let's say this is some y and this is some value, right? Let's say this is 5. Okay, I cannot, okay, let me just write this here. This is 5. So this will be basically 5 into y. Sorry for the noise, basically I'm really sorry, there is some construction work going on in the background. 5y divided by 2 into the cos of the angle between them. All of them are positive, so that is fine. Cos of the angle is 15, right? 15. Theta v minus theta I, so it will be minus 15 because it does not matter here because negative and positive both are okay. So it is theta v minus theta I. If you ever get confused with this negative sign, I will tell you a alternative. So what is the formula of power? Formula of power is Vm Im by 2 cos, I'm really sorry for the background noise, theta v minus theta I. So you can convert this negative sign. What you can do is you can write this negative sign inside the theta angle, right? It will be omega t plus 60 plus 180 plus 180. Okay, so basically you can do this, you can simply do this, right? And then you can proceed with simple positive formula. Ultimately you will get the same answer, trust me, you will get the same answer if you do 180, right? If you just take this negative sign inside, because if you are worrying about the negative sign, if you are getting worried, stressed, so I have other ways to remove the stress as well, but I cannot remove my stress. That is the only problem. You guys can remove my stress. Okay, so Yeah, so I hope you have got this shortcut and all those things. So this is a very very nice and neat trick. Okay, so same thing I want you to solve in this question. You can pause the video and try it out yourself. What will be the average power here? Will there be any average power due to this 3 omega component, 5 omega component? No, there will not be any average power due to the 3 omega, 5 omega component. Homework for you is try it out. Try this formula. P average equals to integration from 0 to t 1 by t v of t into I of t into d omega t. Try it out. Okay, method 2 I will use the shortcut. Okay, because we love shortcuts. So method 2 is very very simple. Simply the what is the matching frequency here? Only this component is the matching, right? Other components we have 3 omega, but I don't have any 3 omega in the voltage. So simply it is VMIM power equals to VMIM by 2 into cos of angle between them. So this is due to the omega component, right? For all others it is simply 0. So it will be VMIM into cos omega t. So it will be 100 into 10 divided by 2 into the power factor. What is the power factor? Basically theta v minus theta I. Theta v is 0, sin omega t is reference, and theta I is minus 60. So this will be 0 degrees minus of minus 60. So this will be 500 of cos 60 1 by 2. So this will be 250 basically. $250. This will be the simple answer. You will solve with the method 1, you will get back to the same answer only. Orthogonality property, that's it. Simply use the orthogonality property. Okay, but one very important point is many educators I have seen, they do this mistake. Let's say you have found out the average power, and we know the power power triangle, right? Because I know mod of a square equals to under root of p square plus q square. So what they do is they say that from here, right, I know the power, active power, I know the apparent power, right? It is simply product of voltage and current. What is the product of voltage and current? What is the product of voltage? It is simply 100, correct? 100 by root 2 basically, right? 100 by root 2. What is the RMS value of current? All these are orthogonal, right? So I can individually square the RMS and then add, then take the whole under root. So this will be first one RMS whole square 10 by under root 2 whole square plus 2 by under root 2 whole square plus 5 by under root 2 whole under root. Okay, so this one will be 50 plus 2 plus 12.5 whole under root. So this, right, almost comes out. I will just calculate this value. This value will be 50 plus 2 plus 12.5 whole under root. So this value will be 8 point, okay, something happened, 64.5 whole under root 8 point. Okay, so this is the current, this is the voltage basically. Okay, now your apparent power will be what? It will be simply voltage into current, this into voltage. Voltage is 100 root 2. So apparent power is fine. So apparent power will be something 567. 567.8, okay, volt ampere. 567 volt ampere. Now few teachers and few students also okay, I have, like, I'm not blaming any teacher, but a few teachers I have seen, they what they do is they write that Q is equals to this S square minus P square whole under root. Now this is actually wrong. Why? Because reactive power, right, reactive power is not defined, reactive power is not defined for multi-tone signals. It is not defined. It is not defined basically, okay. So you will not be able to find out the reactive power. This is not the value of reactive power, right? This is not, this relation is not correct in case of multi-tone signals, that is multi-frequency, that is when you have harmonics. When harmonics are present, the above equation is not correct, the above equation is incorrect. So be very careful. Why is it not correct? Why is it not correct? Because what is reactive power? For reactive power, we have to find out current which is 90° out of phase of voltage. Correct? That is the definition of reactive power, if you remember. Now I have these two signals, right? These are the signals basically. So where is the signal? Yeah, here is the signal, right? So okay, fine. So for this, right, for this component you can say that for this component, yes, the 90° out of phase component will be somewhere, right? So basically my this phasor is here, voltage is in the reference, current is here, and of course 90° out of phase of this voltage will be somewhere here. That is correct. This is the voltage, this is the current, and this is 60 degrees. Okay, fine. What about this? What about this? Is it in the same phase of the voltage? Is this in the same phase of the voltage? You cannot comment. You cannot comment because what I told you, phasor is just like a rotating vector. So this phasor is rotating at a different speed. So I have this voltage and current, right? This voltage and current I have. So phasor is just like a rotating vector. So this phasor is rotating at a speed of omega, same as this phasor. This is also rotating at a speed of omega, but the difference is there is always a phase difference of 60 degrees. So that's why I can draw them both in the same phasor diagram. Okay, both are rotating at same speed. Both rotate at same speed. Omega. Okay. What about this one? So this rotates at a speed of 3 omega and this rotates at a speed of omega. So this is rotating, is it faster or slower? So frequency is more, so of course it will be more faster. Okay, so this is rotating faster than the voltage, right, omega. So the phase difference will keep on changing. Phase, so if I have two components, if I have a omega and 2 omega or 3 omega, let's say, the phase difference is not constant, it keeps on changing. Okay, so it will keep on varying. So it is not defined basically. So you cannot find out the phase difference. If you cannot find out the phase difference, you cannot find out the 90° out of phase component of the voltage. So you cannot comment about reactive power. So reactive power is not defined for multi-tone signals. So I have told you the actual reasoning as well. You will not find it anywhere in YouTube, anywhere. Okay, you search for it, you will not find it anywhere else. Okay, so yeah, that was about the voltage and currents. So yeah, that is, I hope you have understood this point, and orthogonality property also you have understood. Okay, I basically explained how to add the power components, but reactive power components you will not be able to find out. For multi-toe signals, you have to individually find out the reactive power. How you can individually find out the reactive power, that you will understand in power electronics. That we will discuss later. Okay, that is not the part of our this what do you say, scope of network theory. Okay, so these were few important points that I needed to mention. So I will delete these pages. These can be deleted. Yeah. So power factor angle cannot be used to calculate reactive power in presence of harmonics. So like we know reactive power, right, is equals to basically S, magnitude of S into sin phi. This also I have derived, right? How it comes? So basically what is your cos phi? Cos phi is P by S, right? So we have a power triangle here. This is my P in the real axis. This is my Q in the imaginary axis, and this is my S, magnitude of S. Okay. So that is the case. So of course from here, right, this is my phi angle. So from here you can directly say what is my sin phi, cos phi, all those things. So sin phi will be basically, sin phi will be the height upon the base. So it is Q upon the magnitude of S. So but this is only valid for, because this is a phasor diagram, right? This is only valid for a single frequency component. This is not valid for multi-frequency component, not valid. Okay, this will go invalid. So don't use this. So your power factor formula, that is Q equals to Vi sin phi, that you learn, right? Because S, magnitude of S is simply magnitude of V into magnitude of I. That is a very very basic thing. Magnitude of V into magnitude of I sin phi. So that also will not be valid basically. That also will not be valid for multi-frequency. So for single frequencies it will always be valid. For single frequencies it will always be valid. Okay, so this was the last question that I gave you as homework. So this we will solve, and I will give you homework more questions, and in the next lecture we will solve all those questions. So this is the first question. The input voltage of a converter is given, input current of of that same converter is given. Okay, so first they are asking the input power factor. So power factor is always defined. What is the definition of power factor? Definition of power factor, cos phi, not cos phi, sorry, power factor. So don't write cos phi, write power factor. Okay, that is a better notation basically. So power factor is basically P into magnitude of S, P divided by magnitude of S. So I hope you can easily find out the power now. So what power will only be consumed due to this same frequency component, due to all the other components it will be 0. So ultimately it will come out to be basically, this will come out to be Vi cos phi, right? P will be Vi cos phi, so 100 root 2 Vmim by 2 into cos of angle between these two. Angle between these two is pi by 3. Pi by 3 is 60. Okay. So this is 1000 by 2. So that is 500 watts. Okay. So that is the power basically. That is the power. Okay. What about the apparent power? Apparent power is basically magnitude of voltage into magnitude of current. So magnitude of voltage is 100 root 2, magnitude of current is what? Now how do you find out the magnitude of current? So it is magnitude of RMS voltage and magnitude of RMS current. So Vrms is very simple, it is just a single component. Vrms is equals to 100 divided by root 2 and Irms is basically 10 by 10 root 2 whole square plus 5 root 2 divided by root 2 whole square plus 2 root 2 divided by root 2 whole square. Basically the individual RMS whole squared, then whole under root, right? They are orthogonal, they are all orthogonal. So this will be 10 square plus 5 square plus 2 square. So this is 100 plus 25 plus 4 whole under root. So this is equals to 129 whole under root. So 129 whole under root is simply 11 point 11.36. 11.36 is the RMS value of the current. So what will be my apparent power? It is the magnitude of the RMS voltage into RMS current. So this will be 100 times this. So it is 1135.78 volt ampere. So ultimately, right, into the power is 500. So power factor ultimately comes out to be 0.44. Okay, and like then from here, right, how can you say what either it is lagging or leading? Basically, you can see the fundamental component. So don't worry if you don't understand this fundamental component, all those things. This will be taught in signals and of course in power electronics as well. So you don't have to take a stress. So fundamental component is basically this one, right? Fundamental component is this one. That is the like the lowest frequency is generally the lowest frequency is the fundamental component. So what is the fundamental component? That also you will get cleared. That also will get cleared in the machines. Okay. So fundamental component is this one basically. So if you see that the fundamental current is lagging the fundamental voltage, that means it is a lagging power factor. Okay, it will be a lagging power factor. So don't worry if you don't understand fundamental, because this question, right, trust me, no educator will take this question in network theory. Everyone, network theory teacher will say this question is for power electronics. Power electronics teacher will say this question is for signals. Signals teacher will say this question is for network theory. Okay, so no one will take this question. So I am still taking it because I know there will be doubt in your mind. So we have already find out the power factor, and of course we have found out the power as well, because they have asked the active power drawn by the converter. That we have already at the starting itself we have solved. So answer will be B and all B's. Okay, 0.44 and 500 watts. So I wanted to leave with few questions as okay, let us do these questions only, or let us try to do these questions. Okay, let us solve this question in one go only. In this lecture only, let's solve all the questions. So what I will do, I will just show you the questions. I will pause the video and then like you can solve this. So this is the first one. Okay, and this is the second 40. This is the third one, fourth one. Okay, there are actually lots of questions actually. Fifth one, sixth one. Okay, that is the last one only. This is the last one. Okay, so these are a bit lengthy, so pause the video, try it out with yourself, and then I will come back with all the solutions. Let's solve this question. Basically, we have been given a AC source and RMS voltage is 20. Okay, 20 volts is the RMS value. Now they have here, right, in the question they have told RMS voltage 20, and here they have written 20 angle 0. That means what? That means they are telling me that this is the RMS value. This is the RMS. Okay, that's how you will understand whether this is RMS or peak. Okay, be careful. Now your impedance is this internal impedance, and it feeds a load with the impedance as this. You have to find out the reactive power consumed. Now this is a series circuit. So for a series circuit, what is important? Reactive power consumed by what? Reactive power consumed by the load. So reactive power consumed by this element, not due to the internal resistance. So for a series circuit, I have already told you the reactive power. Okay, what is the value of the reactive power? Value of the reactive power is magnitude of I square into X, right? This I have derived in the previous lecture. So XL basically. So I have to find out the magnitude of IRMS whole square into XL basically. Okay. So I can directly write this is the reactive power consumed by the load. So I just need to find out the IRMS. How do I find out the IRMS? So there are many ways to solve. We will solve with both ways. Okay. So first one is find out IRMS. How do you find out IRMS? What is I? I is equals to V by Z, right? What is the overall impedance? V is this 20 angle 0 only. What is the overall impedance? Overall impedance is this 1 plus 2j plus 7 plus 4j. So 1 plus 2j plus 7 plus, this is series circuit. This is a series circuit, 7 plus 4j. Okay. Now if I write down the current, so this will be 8 plus 6j. So this is 20 angle 0. Okay. and this is 8 plus 6j. Okay, so if I divide by 2 on both sides, this will be 10. Angle 0, and this will be 4 plus 3j. So ultimately, right, this will be like 5 angle 10 divided by 5 angle 30, is it 30? Yeah, 37.86. Am I correct? Let me just check. 3 by 4 tan inverse 36, sorry, not 37, sorry, 36.86. 36.86. Okay, so from here you can directly find out the value of I or IRMS in this case, because what is this? This is RMS, right? So if this is RMS, this will also be RMS. I don't care about Z. That's why we told you that Z, right? You don't have to care. Just convert in polar, rectangular. No, it will not matter. What will matter is the voltage. Is the voltage is in RMS. If the voltage is RMS, current will also be in RMS. If the voltage is in peak, current also will be in peak. So just be careful regarding that. So here, this will be 2 angle 36.86. Okay. So now from here I can directly write the RMS value, IRMS, equals to 2. Magnitude of IRMS is 2. So my load, right, will be what? Reactive power consumed by the load will be magnitude of IRMS whole square, that is 2 square into XL. What is XL? XL is 4. Value of XL is plus 4, right? So it will be plus 4 basically. Why plus 4? Because it is lagging. If it was leading, I would have written minus 4 here. Okay. So this will be 4 into 4, that is 16 VAR. 16 VAR. This is my reactive power basically. This is my reactive power. Okay. So now what you can do is there any other way to solve this? Yes. Other way to solve is simply you find out the complex power of this load SL. SL will be what? VL into IL conjugate. Okay. So IL is I only. So I we have already calculated. So this is fine. What is VL? So VL, for VL, right, you have to use the voltage division. So VL, so this is the method 2. So VL will be the volt. Simply this is a series circuit, so it is the voltage division rule. So it will be V input into 7 plus J4 divided by 7 plus J4 divided by 1 plus J2 plus 7 plus J4. So this is 20 angle 0 into basically 7 whole square plus 4 whole square 8.062 angle 4 divided by 7 tan inverse 29.75 degrees. Okay, divided by, this is basically 8, not 8, sorry, 2 into 3 plus 4j, same thing only, sorry, 4 plus j3 basically. So ultimately, right, this will come out to be uh, 20 divided by 2 is 10 into 8.062. Something is okay, nothing is off. We have to divide by 5 as well, right? Okay, something is gone. 10 into 8.062 divided by the magnitude 5, so it comes out to be 16.124, And what is the angle? Like I have written the magnitude here, right? Angle will be 29.75 minus 36.86. So this value will be minus 7.11 degrees. Okay, volts. Okay, this is the load voltage basically. So now I can use the formula SL equals to VL into IL conjugate. VL is how much? 16.124. IL is how much? This is minus 7.11 degrees. What is IL? IL is basically this, right? 2 into minus 36.86. So this will be IL conjugate, so it will be plus only. Angle plus 36.86 degrees. Okay, so this will come out to be 16.124 into 2. This is 32.25. And what is the angle? Angle is 7.11 plus, okay, this is minus plus 36.86. So this will be 29.75. So from here also you can directly find out the reactive power. What will be the reactive power? Reactive power will be Vi sin phi, right? Active power will be Vi cos phi. Reactive for a single frequency component, reactive power will be Vi sin phi. So from here, if I write the sine of phi, right, so it will be simply uh, the reactive component. So 32.33 into sine of this angle 29 point something into 32.25. It comes out to be 16. Okay, which we derived here as well. Okay, same thing, 16. So this, right, you can write into components P plus JQ. So that is what I am doing, PL plus JQL, right? So I am just taking the QL component. Okay, I hope you understand. So this is also another way to solve this question. Okay, so yeah, there are, now what you can do, you can individually find out this reactive power, and if you add the two up, and if you find out the reactive power supplied by the source, you will see, you will observe that both of them are same. Both of them are same only, there is no difference. Okay, so that is the way that you solve this question. Let's move on to the next question. So here we have an RLC circuit basically. Okay, currents, all these things are given. The power dissipated in the resistor. So what is the power dissipated in the resistor? If it is a series circuit, you will always use what? Magnitude of IRL, because this IRL is same as IR whole square into R. What is the magnitude of IRL? It is under root 2. It is under root 2 whole square into R. R is what? R is what? Okay, they have not given us the R. So R is unknown to us. R is unknown to us. For now, let's keep it. Let's keep it. So this is basically 2R. What other information I have? I have the information about IS, the supply current. Supply current is actually, if this is the reference, okay, supply current is actually here, pi by 4 under root 2. Okay, where is the other IRL? IRL is minus pi by 2, so it is somewhere here. Okay, IRL is somewhere here. This is the IRL, correct? This is the IS. Okay, and this is the IRL. Okay, so what about the capacitor current? So the capacitor current, right, basically, if this is the supply voltage is here, this is the reference, right? Supply voltage is here in the reference. So of course capacitor current leads the supply by 90 degrees. So of course it will be here. It will be here, I see. Okay, now the interesting fact is basically IC plus IRL will give me this value, right? And IRL is actually just my pi by 4. Do you understand what does pi by 4 means? Do you understand this? So pi by 4 basically means what? Pi by 4 basically means the real and the imaginary part are same. That is how we get, right? So basically what is the impedance ZRL? ZRL is basically Vs by IRL, right? For this particular two nodes, what is the impedance seen across these two nodes? It is the voltage across the two nodes divided by the current I know, that is IRL. So it is basically Vs by IRL, which is 1 angle 0 divided by IRL. IRL is under root 2 minus pi by 4. So this will be basically 1 by root 2 into plus pi by 4. Now you might have a doubt, sir, what if this is RMS, this is peak? No. So here, right, it won't matter, because if both are peak, ultimately that factor, right, peak factor will automatically get cancelled. If both are RMS, automatically that same factor getting cancelled. So it does not matter. For impedance, it does not matter basically. We don't need the information whether this is peak or RMS, because automatically as we are dividing, that same factor will simply be cancelled. So this will be plus pi by 4 here, and now I can say that what I can say, this is the impedance, right? So from here, can I write this in terms of like series circuit? So it will be R plus jXL, right? So it is 1 by root 2 cos theta, so it will be 1 by root 2, so this will be plus half plus j half. So R comes out to be half. So ultimately your power comes out to be 2 into 1 by 2, that is 1 watts. Okay, this is what your power comes out to be. So option B will be correct. Let's see the option like last question. IC, what will be the current IC? So IC, right, is voltage by impedance, correct? Or otherwise, I know IS, I know IRL. Will I be able to find out IC? Yes, very simply, right? What is the KCL? KCL in this node, if I apply KCL in this node, it is IS equals to IRL plus IC. Okay, and IS is what? IS is basically IC is 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 this, right? This value IS is this, and IRL is this. So IS is root 2 plus pi by 4, and IRL is root 2 minus pi by 4, correct? Minus of IRL root 2 minus pi by 4. Okay, so this value IC this value will be equals to basically root 2 into 1 by root 2 plus j 1 by root 2 and minus root 2 into 1 by root 2 minus j 1 by root 2. So IC will be equals to 1 plus j 1, okay, minus 1 minus j 1. So ultimately this comes out to be plus 2. So IC is plus j2, that is present in the option D. So option D will be the correct answer for this particular question. Okay, so let's now solve the next question. Let's now solve the next question. So this question we have to find out the total power dissipated in the circuit. Total power dissipated in the circuit shown below is 1 kilowatt. So the total power dissipated in the circuit, that is total power delivered by the source, is 1 kilowatt. So they are asking what will the voltmeter read. Okay, if the voltmeter across a load reads 200 volts, then what is the value of XL? If the voltmeter across a load reads 200 volts, then what is the value of XL? Okay, what is the value of XL if the voltmeter reads 200 volts? So basically, I know the power sent, right? The total power sent. So this current is 2 amperes. Across this series circuit, this current is 2 amperes. So what is the power delivered to this 1 ohm? So power delivered to 1 ohm will be I square into R, that is 2 square into 1. So it is 4 watts. Got it. Okay. What is the power here? What is the power here? So through here current is 10 amperes. Through here what is the current? It is 8 amperes. Now is it 8 amperes? Is it 8 amperes? Can you apply KCL here? No. You cannot, because these are phasor. In the starting, right, in the initial phasor diagram, these are all phasor. You cannot apply here, simple algebraic subtraction or addition. You cannot do that. Not allowed. Not allowed. What you can say, instead of this 8 amperes, you can say here this current will be something, let's assume this current to be IC2. Okay, phasor IC2. What will be this current? So whatever is the incoming current, same current should be outgoing, correct? Correct. Whatever is the incoming current, same current should be outgoing. Of course, it has broken down into two parts. Then again, at the end, it is combining. So here also, it will be 10 amperes only. So it does not matter. So even though students did not have the total knowledge, this is a gate question. Basically, this is a gate 2014 question. Gate EE 2014 question. Even though students did not have the idea, still they apply this KCL. Okay, but ultimately answer was same, because ultimately, right, KCL will follow. So this will be 10 amperes only. Another important property of voltmeter, if you have studied measurement, or if you know basic thing about voltmeter, is that voltmeter has very high impedance. So due to its high impedance, there will not be any current flowing through it. So for measurement, guys, this basic information I think you should know. If you don't know, now you know. Generally for EC, not for measurement, for EC, guys, I am saying, if this kind of question comes, just two things you have to keep in mind. Whenever there is a voltmeter, replace it with a resistance of infinity. Whenever there is ammeter, replace it with a resistance of 0 ohms. These two things you just remember. These two things you just remember for EC. For EE, you are already expert and you will study measurements from me, so no problem. Okay, in measurements, all these things are cleared. But for EC, guys, I am telling, whenever you see a voltmeter, just replace it with a resistance of infinity. Whenever you see a ammeter, you just replace it with a resistance of 0 ohms. Okay, that's it. You can write it down as well. So has its resistance is infinity, of course no current will flow here, all of the current will come here only, because current chooses the least resistive path. So I come here, so of course through the resistor as well, the current is 10 ampere only. The magnitude of the current is 10 ampere. Of course, they have not given me any phase, so I will not be able to comment about the phase, but magnitude will be 10 amperes, because here they have told me. So magnitude I know. So what is the power delivered in this resistor R? It is IRMS, I whole square R into R. So I, magnitude of I is 10, so it will be 100 R. Okay, and they have told me the total power delivered is 1 kilowatt. There are no other elements except these two resistors which can actually consume power, because only resistance can consume active power. That already has been taught. So only resistance can consume active power. So this will be basically equals to, like, addition of these two powers. That overall power will be 4 watts, 4 plus 100 R. This will be equals to 1000 kilowatt. Okay, 1000 watt. So this will be R equals to 996 divided by 4. So this will be basically 249. Okay, this will be my value of R. 249 is the ohmic. Am I correct? That is what I am trying to observe. 10 square is 100. Okay, 1 kilowatt. Okay, divide. Okay, sorry. This is divided by 100, right? What am I doing? what क्या कर रहे हो बेटे, क्या कर रहे हो, 100 divided by 100. So if this is divided by 100, this will be 9.96. So that was a mistake on my behalf. 9.96. And what have they asked? They have asked us to find the XL. I know the voltage across this series combination. I know the current across this series combination. If I want to calculate the magnitude of impedance RL, what is it? Magnitude of voltage divided by magnitude of current. So what is the magnitude of voltage? Magnitude of voltage is 200. What is the magnitude of current? Magnitude of current is 10. So magnitude of voltage is 200 volts. Magnitude of current is 10 amperes. Okay. So it will be 20 ohms. It will be 20 ohms. That's it. Okay. This is equals to what? This, right? Magnitude of impedance is equals to what? Basically R square plus XL whole square. Why? Because Z is equals to R plus JXL. Correct? This series combination. So that's how we came to this conclusion. So my ZRL, that is 20, equals to magnitude of 9.96 whole square plus XL whole square. Okay. So it will be 20 whole square minus 9.96 whole square. Okay, 20 whole square minus 9.96 whole square whole under root will be my XL. So XL comes out to be 17.343 ohms. Okay. So this is my XL basically. This is my XL value. Okay. So this will be your answer for the question. And this is how you solve the question. Of course, it is taking me time to explain, but if you are in the exam hall, you will be able to solve it much quicker. Let's move on to the next question. So the next question is basically this: in the circuit, we have two voltage sources which have different frequencies, and they are asking the power consumed by the 1 ohm resistor. So in these cases, right, what you do? So you can use superposition. So whenever there is a multi-tone signal, multi-tone frequency, multi-tone, you can use the superposition. Okay. So first I will make this source 0. I will take into effect of this source. I will calculate the power, and then I will calculate the power due to this source. I can add the powers because they are orthogonal. This is only valid if signals valid power can be added only if signals are orthogonal. We have already done some problems like this. Only if signals are orthogonal. Okay. So this will be so first I will take into effect of this source, basically this one. So this will be what will be the current due to this source? So current due to this source will be simply voltage by the impedance, right? So impedance, right, is frequency dependent here actually. So if I take this first source, if I take the first source, this is R and this is XL basically. Okay, so XL is here 1 millihenry, so this will be basically J into omega L. Omega in this case for the first frequency I am only taking, so right now I am considering the first source 10 under root 2 sine sine 1000 t. Okay, so this will be 1000 into t. T is basically 1000 into omega. Omega L basically, omega is 1000, so L is 1 millihenry, so it will be 10 raised to power minus 3. So basically it is J only. And what is R? R is 1 ohm. So the impedance in this case is what? Impedance is basically V. V is 10 root 2. I am taking the peak now, divided by the impedance, that is under root 2. You can calculate. I am directly writing angle 45 plus 45. Okay, so the current actually comes out to be 10 angle minus 45 degrees. So they are asking power consumed, right? So current is this. This is the peak, right? Because I have assumed this, I have taken the peak value here. So this also will be the peak. So what is the power basically? Power, right, will be IRMS whole square into R. So IRMS is 10 divided by under root 2 whole square into R. R is basically 1 ohm. So this will be 100 divided by 2 into 1, 50. 50 is 50 watts. Okay, it is 50 watts. So that is the power consumed by the first source. So what about the second source? What about the second source? Second source is this 100 root 2 cos 300 t. So this is 100 root 2, not 300, sorry, 3000. So 100 root 2 cos 3000. So this time, right, my assumption is cos 3000 is the reference. Previously sine 1000 was the reference, 1000 t was the reference. Now cos 3000 is the reference because the circuit has changed. Because the circuit has changed basically. So what is the current here? Again the current here will be V by Z. V is 10 root 2, 100 root 2. Okay, what about the Z basically? Z has changed now. Z is not this anymore because omega has changed. Omega is 3000. So this actually is J3 now. So it is 1 plus J3. Okay, so this one will come out to be 100 root 2 divided by under root 1 plus 9. And angle is what? Tan inverse 3. So tan inverse 3 is 71.56 degrees. Hundred under 2 divided by 10 under root 4.721. Okay, angle is minus 71.56 degrees. Okay, so now like from here I can directly write the again the like the power, right? Okay, I can directly write the power. So what will be the power in this case? It will be again IRMS square into R. So IRMS square into R, if I do, power in this case IRMS square into R. Okay, remember this is the peak, right? This is the peak. So of course don't forget to divide by root 2 as well. So it is 44.721 divided by root 2 into R. R is basically 1 ohm. Okay, so this will be 44.3 divided by 2000. So this will be 1000 basically, 1000 watts. So what is the overall power consumed? Overall power consumed will be the addition. This I will only be able to do as signals are orthogonal. Because signals are orthogonal, that's why I can do it. That's why I can do it. Or what other way you can do? You know the IRMS of this RMS component. This is the IRMS. You know the RMS of this, right? RMS of this is 10 by root 2, 10 by root 2. So these RMS values are what? This RMS has a frequency of 1000 T, this RMS has a frequency of 3000 T. So overall RMS, overall power will be what? Overall power across the resistor will be what? Overall RMS current into square into R. What is the overall RMS square? IRMS whole square. The overall RMS whole square, because one has the frequency component of 1000 T, one has the frequency component of 3000 T, I can simply do this, right? I can simply do this. That is, this IRMS is 10 divided by root 2 whole square, individual RMS plus 100, not 100, sorry, this is what, 44.721, 44.71 divided by root 2 whole square whole under root. Okay, so this will be basically what, this like same thing, right? Same, it is same as adding powers only. So this will come out to be 10 by under root 2 whole square. This will come out to be 1050 only. Okay, not 1050, sorry, yeah, this will come out to be not 1050, under root 1050 whole square plus 44.721 divided by 2 under root. Okay, just hold on, 44. Okay, this I will not be able to add individually. 7.07 whole square, 7.07 whole square, 50, 44.721 divided by under root 2 whole square. This is 1000. Okay, and this whole under root is the IRMS basically. But what do I need? I need to find out the power. Power is what? Whole IRMS into whole square into R. So whole IRMS is what? 1050 whole under root into whole square into R. R is 1. So ultimately this comes out to be 1050 watts. This is your answer. That's why you can add the powers, because signals are orthogonal here. As signals are orthogonal, that's why you can add the powers basically. Okay, so now let's finally come to our last question. I know this lecture is long, okay, but of course we have to finish things up. Okay, so we will solve this question basically. We have to find out the complex power delivered to both the loads here. We have to find out the complex power delivered to both the loads. So what I observe is, this is the voltage and these are like the powers, right? So this load is taking 10 kilowatt at a power factor of 0.8 leading. This load is taking 10 kVA, that is apparent power, at a power factor of 0.8 lagging. So they have given me the individual powers. So whatever we are discussing, as they have mentioned here phasor, so we are discussing about single frequency component. So we, first of all, first point we should keep in mind is, we are discussing about single frequency component. Okay, that is what we are discussing about. So next, if we are discussing about single frequency component, so of course I can say active power can be added individually, separately, and reactive power can also be added. Active power and reactive power can be added separately. Same for reactive power. Okay, same for the reactive power basically. So what I can say is that why is it the case? If you see, some current is going here, right? Some current is going here. Okay, let's say this is some I1 current, let's say this is some I2 current. Okay, overall apparent power S is equals to P plus JQ, correct? So this apparent power, right, can be written as a combination, because this, what is the apparent power consumed by this S1 will be V into I1 conjugate. What is the apparent power consumed by this S2 is V into I2 conjugate, correct? If I add these two, S1 plus S2, what will I get? It will be V into I1 conjugate plus V into I2 conjugate. If I take V common, this will be I1 conjugate plus I2 conjugate. Can I rewrite this? And will you be satisfied with that? If I rewrite this, will you be satisfied? V into I1 plus I2. Okay, comment down below. If you are satisfied with this, comment down below. I have studied class 12. If you are not satisfied, you will comment, I have not studied class 12. Okay, that is what you will comment now. So yeah, if I do this, right, it is what? I1 plus I2 is what? I1 plus I2 is basically this I, right? I1 plus I2 is basically this I. So it is simply equals to Vi conjugate. That's it. Simply equals to Vi conjugate. So it is simply equals to S. So S is equals to S1 plus S2. So I can do that. And what is S1 and S2? So S1 is S equals to P1 plus JQ1. S2 is equals to P2 plus JQ2. So now if I rewrite, S will be equals to P1 plus P2 because they are similar type of objects I can add, plus JQ1 plus Q2. Okay. So that is the case over here. That is the case over here. So that is why we can add. Okay. Now I hope this point is clear. Now let's individually calculate the powers basically. So S1, I don't know what is S1, but something they have told me that P1 is 10 kilowatts. This much information I know, and the power factor is 0.8 leading. Can you find out Q? Can you find out S1? So magnitude of S1 will be what? There is a formula, right? Power factor. What is the formula of power factor? It is P1 by magnitude of S1. So it is, what is P1? P1 is 10 kilowatts. P1 is 10 kilowatts divided by magnitude of S1. What is power factor? Power factor is 0.8. So magnitude of S1 will be simply 10 divided by 0.8 kilowatt. Okay. So it is 10 divided by 0.8, I think is 12.5, something like that. 10 divided by 0.8. 12.5. Okay. 12.5 kVA. So yeah, that is the case over here. That is the case over here. And what is the Q then? So Q, right, it is a single frequency component, is simply magnitude of S1 sin phi. Okay. What is phi? Because this is cos phi equals to 0.8, sin phi will be 0.6. Okay. I hope you basic trigonometry is clear, right? Basic trigonometry is clear. Important point is this will be 12.5 into 0.6. So that is basically 4 by 5. That is I think not 4 by 5, 3 by 5. That is I think 7.5. So 12.5 into 0.6 is 7.5, I guess. Yeah, 7.5. So this will be 7.5, I guess. Okay, 7.5 kVAR. But will it be plus or minus? Will it be plus or minus? Pause the video and say me, will it be plus or minus? Of course, it will be minus, because lagging reactive power is positive, leading reactive power is negative, and they have told me that this load is lead. So of course, it will be negative. That is the reason. Okay, there are many ways, many other ways to solve as well. Okay, you can solve with other ways as well, but I will solve with this method only. Okay, there are other ways to solve. You can comment down below what other way you have found out, so you can solve using that method as well. What about the Q2? Q2 will be what? P1 I have found out. Now let's discuss about Q2 and P2. So find out the complex power delivered to both the loads. So first one, right, what is the complex power? What is the complex power to the first load? Complex power of the first load is magnitude of S1 into angle of theta 1. So it is basically magnitude of S1 is 12.5. What is angle of theta 1? So theta 1, right, is simply cos inverse that. I think it is 37.86, something like that. 0.8 cos inverse. Okay, so 36.86 minus 36.86. Why minus? Because it is a leading reactive power. That is why it is minus. What about the S2? All these are phasor quantities. Now S2, right, they have already given me that it is 10 kVA and 0.8 lag. So if S2 is 10 kVA and 0.8 lag, so this will be 10 kVA only, magnitude of S2. This isn't in kVA. 0.8 lag. 0.8 lag means this will be plus 36.86. That's it. What is my phi 2? It is cos inverse 0.8. As it is lag, that's why it will be positive. Okay, so this is kVA. Okay, so now can I add the powers individually? Of course you can. You can individually write down the powers as well. What will be the power here? P2 plus JQ2. So this will be like active power will be 10 into cos 8. So this will be 8 kilowatt plus this will be 0.6 into 10, that will be 6 kVAR, JkVAR. Okay, and for this we have already written the active and reactive powers. Active power is 10 kilowatt, that was given in the question, minus J 7.5 kVAR. Now individually you can add these things up because these are all similar objects, and individually you can add these two objects. So overall your apparent power will come out to be S1 plus S2. This will be 10 kilowatt plus 8 kilowatt minus J plus J into 6 kVAR minus 7.5 kVAR. Okay, so this will be 18 kilowatt minus J 1.5 kVAR. So overall the load is what? Load is capacitive. Overall the load is leading actually. That's why I am getting negative reactive power. So overall the load is capacitive. Okay. So is there any other way? So other way is simply like I have already derived. Other way is, one thing you can do, overall complex power if you want to find, you already know the voltage across this, right? You already know the voltage. Individually you find out the currents. How you can find out the currents? This is given, right? So method 2 is simply, I will just briefly explain that this load is consuming 10 kilowatt of power at 0.8 lead power factor. So I know, right, P is equals to VI cos phi. So I know cos phi, that is 0.8. I know V, that is 230. I know P, that is 10 kilowatts. So from here you will be able to find out I. Here, right, simple thing is magnitude of S is equals to magnitude of V into magnitude of I. From here also you will be able to find out the value of I. So if you find out the value of I, and then of course you know the angles you know, this is 0.8 lagging, this is 0.8 leading. From here you will be able to find out the value of phi 1, phi 2, and overall I will be equals to I1 plus I2. Okay, and then you do S equals to VI conjugate. Okay, so put it in the comments below if you have done this homework. So this is the method 2 basically. Okay, because this lecture is going long, so just told you, so you can do it, right? I am trusting you guys, so you can do it. Okay, so individually find out the currents and then add the currents ultimate I, then you do V into I conjugate. So V is already same across, it is a parallel circuit, V is same. So V into I conjugate will give you the apparent power. So from there you can solve this question. So that's why I have left a space. So anyways, this lecture is going long, so we will end this lecture, and with this basically our complex power has been finished. So trust me, whatever can be asked from complex power, we have finished it within 4 lectures. Okay, so I hope you have enjoyed this complex power chapter, and from the next lecture onwards we will start with a new chapter, that is resonance. That is also a very, very important and interesting chapter, and for AC, right, mostly questions come from resonance only. For EC mostly questions come from resonance only. So I hope you have enjoyed this lecture. If you have enjoyed this lecture, make sure to like the video, make sure to comment down below which part you enjoyed the most, and I will meet you in the next lecture. Until then, happy learning.